let's have a look at the mirror equation and how we're going to use the calculator to make using the mirror equation a little easier. The mirror equation is that 1 over the focal length, f, is equal to the sum of 1 over the distance to the image plus 1 over the distance to the object. Focal length is positive for a concave mirror because it's out in front, and it's negative for a convex mirror because it's back behind. Virtual images will have negative DIs because they're behind the mirror. Real images will have positive DIs, and of course DO always has to be positive. The object has to be out in front of the mirror. Now we could also write this equation like this, because this is f to the minus 1, DI to the minus 1 plus DO to the minus 1. And I point this out because there's a nifty calculator button. This is to the left, and above the keypad, the numeric keypad, the x to the minus 1 key, and we're going to use that as we do a problem. So let's go to our first problem. So we have this candle. It's 10 centimeters tall, and it's sitting out in front of a concave mirror, 24 centimeters out in front, and the curvature of the mirror is 30 centimeters. And we want to figure out where the image appears and what its size will be. There's a couple things here, and let me get myself a, get a pen to write with. All right, so this says that it's a 30 centimeter curvature. That means that's how far it is out to C, so F will be 1/2 that. So the focal length F will be 30 centimeters over 2, or 15 centimeters. Because in the mirror equation, we have to have F. All right, so here's that same problem written out over here. Let me drag that off of the end. Okay, so the equation is 1 over F, there we go, equals 1 over DI plus 1 over DO. And let's solve it for what we're looking for, which is the image distance. So 1 over DI will be 1 over F minus 1 over DO. Okay, so we can just plug the numbers into that. So 1 over DI equals 1 over the focal length we just figured on the previous slide was 15 centimeters minus 1 over the distance to the object, and that's at 24 centimeters. All right, so now when you punch this into your calculator, you're going to do it like this, and I'll just punch it along with you. So it's going to be 15, and then push the x to the minus 1 key, and then that's going to change the display, and then we're going to push minus and 24, and the x to the minus 1 key, and now this is where it's going to get a little tricky. Now we're going to push enter down in the corner, and it's going to give us a value, and that value is not the answer, that is 1 over DI. So then you're going to push the x to the minus 1 key again. It's going to change the display to answer to the minus 1, and when you push enter, it's going to give you the answer, and so DI in this case is 40 centimeters. Okay, and that 40 centimeters is positive, which means that the image appears out in front of the mirror. Then to find the size, we're going to use that equation high over ho equals the negative DI over DO, and that's just a matter of plugging numbers into and rearranging this. So it's going to be the height of the object, which is 10 centimeters, times the distance to the image, which is 40 centimeters, divided by the distance to the object, which is 24 centimeters. And let's punch all those in.